Hello and welcome back to College Algebra, MAT 150. In this lecture we're going to be solving exponential equations. So there are two ways to solve exponential and logarithmic equations, so both of these methods work for both types. And the first method is to make both sides basically look the same. And then whatever's in the exponents or in the insides of the logarithms, you make those equal to each other. And then the other way is to use inverses or equivalent equations. All right, so when we say inverses, again, if it's a exponential, it's a log with the same base, or if it's a logarithm, it's an exponentiate both with the same base. Or you can just rewrite it as an equivalent equation of the other. So let's take a look at example 1. So we have 3 to the x equals 3 squared. So the only way that this is true is if the exponents are equal, right? So the only way 3 to the x equals 3 to the second is if x equals 2. And this is the idea, the basis behind the idea of problem 1. So if we look at a slightly more difficult version of this, so if we look at number 2, instead of 3 to the x equals 9, the key step to these is to make it 3 to the x equals 3 squared, make them both be 3 to some power. So 3 to the x equals 9, but 9 is the same as 3 to what power? Well, we saw it over there. 3 times 3 is 9, so 3 squared. And thus, x equals 2. So this is the basis behind that solving technique. All right, so if we look at number 3, so we have 4 to the 2x minus 1 equals 64. Can we try this method? Sure. We have 4 to the 2x minus 1, and we want to rewrite 64 as 4 to some power if we can. Well, 4 times 4 is 16, so it's not 4 to the second power. But 16 times 4, so 4 times 4, and then times the other 4, gives us 64, so 4 to the third. And now we have 4 to the 2x minus 1 equals 4 to the third. Only way that this is possible is if the exponents equal each other. So 2x minus 1 equals 3. And then we can just go through our solving techniques. We can add 1 to both sides. We get 2x equals 4 and divide by 2. And we get x equals 2. What about number 4? We have e to the x plus 2 equals 6. And if we tried this technique, we'd have e to the x plus 2 equals e to the question mark power. But how can I rewrite 6 as e to some power? Well, you're going to be thinking about that one because it's a very difficult question to answer. Okay, so you can't use this technique. But what do we know about equivalent equations? Well, this is an exponential. Okay, so with an exponential, what is an equivalent logarithmic equation? Well, the equivalent logarithmic equation has what base? It has a base of e. So log base e is ln. Remember that the outputs for logarithms are exponents. So if I want to change this equation to a logarithm, the output should be the exponent, which is x plus 2. And remember that inputs and outputs swap for logarithms and exponents. So this is the input, it's now the output. The output was 6, and that's going to now be the input for our logarithm. So ln of 6, and then we solve, so we subtract 2 from both sides. Again, this is a logarithm, it's not much we can do. So this is x equals ln of 6, and then we just, after we plug that into our calculator, we would subtract 2. All right. So this is the precise answer. You could get an approximation by plugging this into your calculator. All right. So now we have two methods. Okay. As it turns out, with number 5, we're going to have to use that second method again because we can't think of 6 as rewritten as 7 to some power very quickly. So what is the equivalent logarithmic equation? Well, this is 7 we have a exponential with 7 as a base. So the equivalent equation should be a logarithm with 7 as a base. The output should be the exponent, And remember, the output of the logarithm is now the exponent should now be the input of the logarithm. So we get something similar. X equals log base 7 of 6 minus 2. The only weird thing is log base 7 of 6. Sometimes that's not enough, and we can rewrite this as ln using the change in base formula, ln of 6 over ln of 7, ln of the argument of the inside over ln of the base minus 2. Now, what we've seen so far is that when we have an exponential equal to a number, we could do something. So if we go back and look at some of the other ones, all of these, 1, 2, 3, 4, and even 5, all of them had the exponential by itself. But in number 6, the exponential is not by itself. So that leads us to a new technique we need. So we have to isolate the exponential first. That means we're treating this like a big old x and solving. So if you had 5x minus 2 equals 18, what would you do? You would add 2 first. And then we would divide by 5. Remember, order of operations, we can't multiply the 5 and the 2 because you have to do the exponent first. So 2 to the 3x equals 20 divided by 5 is 4. And now we can actually go back to a way that the first technique we learned. 4 is the same as 2 squared. So the only way this works is if 3x equals 2. So 2 to the 3x equals 2 to the second. So 3x makes it equal 2. We divide both sides and get x equals 2/3 as our possible solution. All right. And that leads us to this last one, number 7. So we have e to the 2x plus 2e to the x minus 3 equals 0. So we have 1, 2, 3 terms. If we see that and it equals 0, that might elicit the idea of factoring. But how do we factor? Usually when we factored, it was like x squared plus 2x minus 3 equals 0. And we could factor that. So if we could see it like that, then it might help. But remember that e to the 2x is the same as e to the x times e to the x quantity squared. Remember, you can multiply, so the exponent, e something to an exponent, and then the whole quantity again to an exponent. That means you can multiply these things. So we could relook at this as e to the x quantity squared plus 2 e to the x, and I'm going to write that in parentheses as well, minus 3 equals 0. So something squared plus 2 times that same something, but not squared, minus 3 equals 0. So we can factor this. And we look for two numbers that multiplied, or we could use the quadratic formula with e to the x equaling our quadratic formula. We could do that technique as well. But here we have this, and we can factor it. So two numbers that multiply to be -3, that add to be +2 are x, e to the x, because that's what we're doing, plus 3, and e to the x minus 1. And now we have two factors that multiply to be 0, so we set each of these factors equal to 0. And then e to the x equals -3, e to the x equals 1. And we have, first off, you can never have a negative output from a positive exponential. And if you did, if you're like trying to solve, we would use equivalent equations. So if you want to do that, ln, the output of, so e is the exponential, so log base e, ln. The input is the output of the exponential. equals x. You can't log negative numbers either. So either way you think about this, you can't do it. But if we do the other way, so we do the other one, the other factor, ln of 1, so log base e, so log base e is ln of the output is now the input, 1 equals the exponent x, and ln of 1 is 0. So x equals 0 is our only solution. And that concludes this lecture.